Today we'll be doing the integral from minus infinity to infinity of the arctangent of 1 divided by 2x squared dx. And to start off, we'll notice that the integrand is even, so we could split this integral into twice the integral from 0 to infinity of the arctangent of 1 divided by 2x squared dx. And from here we'll follow up with a substitution. So we're going to let y equal 2x squared. But that means that y over 2 equals x squared, and solving for x, we have x is the square root of y over the square root of 2, and differentiating, we have dx is 1 over the square root of 2 times 1 over 2 times the square root of y dy, and the bounds of integration here will not change. So we're going to have a twice the integral from 0 to infinity the arctangent of 1 over y times 1 over the square root of 2 times 1 over 2 times the square root of y dy. These two end up canceling. We have a 1 over the square root of 2, the integral from 0 to infinity of the arctangent of 1 over y times 1 over the square root of y dy. And from here we'll make integration by parts. So we're going to let u equal the arctangent of 1 over y, and du is 1 over 1 plus 1 over y quantity squared, and then the derivative of 1 over y will be a negative 1 over y squared times a dy. So we have du is negative 1 over y squared times 1 over 1 plus 1 over y squared dy. Simplifying that, we have a du is negative 1 over y squared plus 1 dy, and dv will be 1 over the square root of y, and integrating that will get a 2 times the square root of y. So using this, we have a 1 over the square root of 2 times the square root of y times the arctangent of 1 over y from 0 to infinity minus the integral from 0 to infinity of v du negative 1 over y squared plus 1 dy. This limit ends up being 0. These negatives cancel to a positive. We could bring down that 2 to the front, and we're going to have a 2 over the square root of 2, and then the integral from 0 to infinity of y to the 1/2 divided by y squared plus 1 dy. And from here we'll make use of an identity. That is that the integral from 0 to infinity of y raised to the s minus 1 divided by 1 plus y to the n dy is pi over n cosecant of pi s over n. So now equating the exponents, we have s minus 1 is a half and n equals 2. Solving for s, we have s is 1/2 plus 1, which is 3/2. So we have a 2 over the square root of 2 times pi over 2 cosecant of pi over 2 times 3/2. These two are gone, and we have pi times the square root of 2, the cosecant of 3 pi over 4. And we know that the sine of 3 pi over 4 is root 2 over 2. So the reciprocal cosecant of 3 pi over 4 is 2 divided by the square root of 2. So we're going to have a pi root 2 times root 2. So we have a 2 pi over 2. The 2's cancel, so we have a pi. So now we can say that therefore the integral from minus infinity to infinity, the arctangent of 1 over 2x squared dx is equal to pi. So that is the final result.